Hello students, today we will go through the first exercise of this chapter, coordinate geometry. That is exercise number 7.1. Okay, the first question is find the distance between the following pairs of points. That means uh, two pairs of coordinates are already given, right? There are three different questions in question number 1. I am just solving one out of them. Let's solve question number 2 here. Let the two given points P A, that is the first point minus 5 comma 7, and the second point B, that is minus 1 comma 3. Okay, now we need to find out the distance between these 2 points. Okay, suppose this is the point A and this is the point B. We need to find out the distance between these 2 points, that is the distance of this line segment. Okay, so here we can directly apply the distance formula. Here this will be x1, this will be y1. No need to write this thing, you just have to think this in your mind. This is x2 and this is, sorry, yes, this is x2 and this is y2. Okay, so the length of AB is equals to, according to distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. Okay, that is x2, that is minus 1 minus x1, that is minus 5 whole square plus y2, that is 3 minus y1, that is 7. Okay, if I calculate this will become plus 4 square plus minus 4 whole square. That gives 16 plus 16, that is root over 32, that is 4 root 2 unit left. Okay, this will be the answer. Now I am going to solve question number 3. The question is determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. Determine if, that means we have to check whether the given 3 points are collinear or not. Okay, here you can see I have assumed that I have taken the 3 given points as A, B and C. I have written them along with their coordinates, right? Now we will assume the given 3 points are collinear and we will move forward by assuming that. Okay, by assuming these 3 points are collinear, we will move forward. We'll see what happens then. Okay, so I have drawn the picture here. See the figure, A, B and C, 3 points. I have drawn them collinear. Now if they are collinear, then the total length of the line segment AC will be equals to the sum of the length of line segment AB and line segment BC. length of line segment BC plus length of line segment AB will provide me the total length of line segment AC. If this happens when these 3 points will be collinear. Okay, so we have to check that. Now AB will become, according to distance formula, 2 minus 1 whole square plus 3 minus 5 whole square, that is root over 1 square plus 2 square, that is root over 5 unit, right? Similarly, BC, the length of BC will be, here we should write length of BC minus 2 whole square to the coordinates of BC, minus 11 minus 3 whole square, that is minus 4 whole square plus minus 14 whole square, right? That is root over 16 plus 14 square, that is 196. That gives root over 212 unit, right? This is 212 453. So this means 2 root 53 unit. Okay. Now the length of AC, that is root over minus 2 minus 1 whole square plus minus 11 minus 5 whole square, that is minus 3 whole square plus minus 16 whole square, right? This is 9 root over 9 plus this is 16 square, that is 256. That gives root over 265 unit. Now see the lengths of AB, that is root over 5 unit, length of BC, that is 2 root 53 unit, and length of AC, that is root over 265 unit, right? Now check whether AC equals to AB plus BC. Check it. AC is root over 265, right? That is not equals to root over 5 plus 2 root 53, right? So these 3 points will not be collinear. Okay, I have drawn this figure to make you understand, and you don't need to write this checking portion in your copy. You can check this in your mind. You just have to calculate the length of AB, length of BC, length of AC. and then you have to calculate in mind whether AC is the length of AC is equals to sum of the lengths of AB and BC. Is that verified or not? If that is verified, then these 3 points will be collinear, otherwise they will not be collinear. Same kind of example, same kind of question is given in the example also. You can see that there the points will be collinear. Okay. Now, okay, let's move to question number 5. Okay, read the question number 5 here. In a classroom, 4 friends stated something about ABCD points. Here the graph has been given here. The points A, B, C, D is marked. You just have to calculate the coordinates of these 4 points A, B, C and D. Okay, then you have to calculate the distance between A and B, that will be the line segment AB. Similarly, line segment BC, CD, AD. Okay, then if all the 4 lengths of 4 line segments AB, BC, CD and DA are equal, then it may be a square, because a square has 4 sides of equal length. But the same thing happens for the rhombus also. To check whether it is a square or not, there is a property of diagonals for the squares. For a square, the length of the 2 diagonals will be of same length. So we have to check we have to calculate at first the length of AC and then calculate the length of BD. If those 2 lengths are equal, then you can say that there is a square. If they are not equal, the length of AC and BD, if they are not equal, then that cannot be a square. Okay. Okay, question number 6 is also, I think, same. Here the coordinates of the points are already given. You have to check whether they are special kind of quadrilaterals or not. Okay. Some may be parallelogram, some may be square, or some might not be anything. That will be a normal quadrilateral maybe. Okay. Question number 7 is, find the point on the x-axis which is equidistant from 2, -5 and -2, 9. Okay. It is given to us that particular point lies on the x-axis, and we know that any point lying on the x-axis will be of the form x, 0, right? So if the given 2 points 2, -5 and the other point is -2, 9, these two are equidistant from this point, then the distance between this point and this point and the distance between this point and this point will be same, right? So by applying distance formula, we can write here, you can write that let the point be x, 0. Okay. Okay. The distance formula, distance between this point and this point is 2 minus x whole square plus -5 minus 0 whole square. That will be equals to distance between this point and this point, that is minus 2 minus x whole square plus 9 minus 0 whole square, right? Here let's take minus as common and make it x minus 2 whole square plus 25, and here it will be, take minus as common, minus square, here it is minus whole square is there, so minus will be omitted if we take minus as common at the front. Then it will become x plus 2 whole square plus 81, right? Now I'm writing this here. If we square both the sides, then we will get x minus 2 whole square plus 25 equals to x plus 2 whole square plus 81, right? Now we will take this term at the right side and this term at the left side. See, this is of the form a plus b whole square minus a minus b whole square. That is the formula of 4ab, right? And here in this side it becomes minus 56, and this will become, applying the formula 4ab, that is 4 into x into 2, so 8x becomes minus 56, right? So x is minus 7, so the required point will be minus 7, 0. This will be the answer. Okay. Question number 8. Find the values of y for which the distance between the points P, that is 2, minus 3, and Q, that is 10, y is 10 units. That means the distance between P and Q is 10 units. It is given to us. Now we just have to apply the distance formula here. That will be equals to 10 units, and from that equation we need to calculate the value of y. Okay, so according to question, applying distance formula, that will be 10 minus 2 whole square plus y minus 3 whole square, that is 10 units. Okay, now simplify it. It's 10 minus 2, that is 8 squared 64 plus y plus 3 whole square, that is 10. This implies 64 plus y plus 3 whole square equals to 100 by squaring the both sides. Okay. Now here I'm doing it here. I'm breaking this in the a plus b whole square formula. Y square plus 6y plus 9. Now calculate 164. 64 will be taken to the right side and that will become 36. Now take the 36 at the left side, that will be minus 36. 0. Right? So y square plus 6y, that is minus 27. Now factorize this expression at the left side. Y square plus 9y minus 3y minus 27 equals to 0. That gives us y plus 9 minus 3 y plus 9 is equals to 0. So y plus 9 y minus 3 is to 0. So either y will be minus 9 or y will be plus 3. Right? These are the answers. Okay. Now next question number 9. It is given that if Q 0, 1 is equidistant from P and R. P is given as 5, minus 3 and R is given as x, 6. Find the values of x. Also find the distance between distances QR and PR. Okay. The Q is equidistant from P and R. Right. So calculate the distance between P and Q, then calculate the distance between Q and R like this. Since they are equidistant, you will be having two expressions both sides. They will be equal, and from there you have to calculate the value of x. After calculating the value of x, you need to find out the distance between QR and PR. Okay. Question number 10. Find the relation between x and y such that the point x, y is equidistant from the point 3, 6 and minus 3, 4. Okay. The relation between x and y, and it is given that the point xy is equidistant from 3, 6 and minus 3, 4. So find out the distance between x, y and 3, 6. Then again find out the distance between x, y and minus 3, 4. Then equate them. They will be equal according to the question, the distances. Then from that expression or from that equation, you will get the relation between x and y. A question in example, that is example number 4 of page number 160, is same as question number 10 of exercise.